With this video, we are going to model some examples from section 1.3, Trigonometric Functions, which is a very essential lesson for this entire course. So before we start solving some homework questions, I want to give you some fundamental knowledge about trigonometric functions. We have 6 of those. We have sine, we have cosine, we have tangents, we have cotangents, we have secant, and we have cosecant. Now, there is more information about all these functions in the course videos. You can go ahead and watch them for more information. But there is some important knowledge that we have to memorize. In order to memorize it, I'm going to show you a riddle that I can probably write like this. So out of these 6 functions, the very first 3 of them, the most important of them are sine, cosine, tangents. Because the rest of the 3, they depend on these main 3 functions. And then here, I put a riddle which is very famous. I can call it as so, cut, so on, which means sine, in order to find the sine is always a ratio between the opposite side and hypotenuse. So to find the sine of any angle, you will calculate the ratio between the opposite side over hypotenuse. So sine is opposite over hypotenuse. So this part, C stands for cosine, A stands for adjacent. So to find the cosine of any angle, from the triangle, you will have to calculate adjacent over hypotenuse. And finally, for the last part, T stands for tangent. And in order to calculate the tangent, you will need opposite over adjacent. Now, so if you remember our basic geometry class, and then when I draw a right triangle, and then if I just draw an angle here, let's say we're talking about this angle, and we want to find the sine value of this angle. So that's another thing. Sine by itself, it doesn't mean anything, but sine of an angle, that's what we're going to calculate for the rest of the trig class. We can calculate the sine of an angle. And here in this case, the angle is alpha. So if you want to calculate the sine value of this angle, this is the opposite side for angle alpha. This will be the adjacent side. And then the slanted side will be the hypotenuse. So if you want to calculate the sine of alpha, you need opposite over hypotenuse. That is this part, so part. S stands for sine, O stands for opposite, and H stands for hypotenuse. If you need to calculate the cosine of this angle, you need to do the ratio between adjacent side and hypotenuse side. If you're just going to calculate the tangent of this angle, tangent alpha is always opposite over adjacent. So one of the main things that I want to give you here before we start talking about the questions, a long sine means nothing. So we always use the sine with an angle. So we say sine of 30, or we say sine of pi. So sine of pi. Or if you don't know the angle, you can say sine of x. But these trig functions, they have to come with an angle value. Or similarly, you have to say cosine of 45. That's what I'm looking for. Or you can say, I need a cosine of pi. Or you can say, I need cosine of x. So all these trigonometric functions alone, these 3 letters, they mean nothing. But if you use them with an angle, that means you want to calculate the cosine value of this angle. That's one of the important things, because sometimes students don't understand that alone sine and cosine, they don't mean anything. So since we said we have a riddle showing that whenever we want to calculate the sine of any angle, so in this case, for any angle, I use the letter x. If you want to find the sine of x, again, I like to draw my triangle. You don't have to draw your triangle this position. Any position is okay. And then when you draw a right triangle, one of the angles is always a 90-degree angle, but then you have two choices to label your x value. Your x can be here or your x can be here. It depends on where you want to place it. I like to place my angle x here. So when I put my angle x here, for angle x, this will be the opposite side. And then this will be the adjacent side. But if you happen to place your angle x here, now for angle x, this will be the opposite side and this will be the adjacent side. So you have to make sure that where are you putting your angle x so that you can label which one is opposite side and which one is adjacent side. Anyway, I'm going to use my first triangle to summarize my information here. So when I draw a right triangle in this format and place my angle x here, this is my opposite side and this is my adjacent side and this is my hypotenuse. And then when I want to calculate the sine of this angle, all I have to do is find the length of opposite side and divide it by hypotenuse. If I need the cosine value of this angle, then I need the adjacent side over the hypotenuse. And then when I need the tangent value of this angle, tangent is always opposite over adjacent. So we have to memorize these three rules, and we have to understand which one is the opposite side, which one is the adjacent side, depending on the angle you position. And again, if you ever forget these formulas, but if you remember this, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, so it's adjacent over hypotenuse, and tangent is opposite over adjacent. So you can always use this riddle to remember the formulas. Once you understand these three main functions, what I would like to do is now, I'm going to drive the other three functions that you're going to see on the questions. We have three other functions besides sine, cosine, tangent, but again, I want to highlight that sine, cosine, and tangent, these are the three fundamental trig functions, but we have total 6 of them. Now, reciprocal of tangent is called cotangent. So cotangent of x is always the reciprocal of tangent. So that means if you need to find the cotangent of an angle directly, instead of doing opposite over adjacent, you basically do adjacent over opposite. That's how you calculate the cotangent of an angle. Now, reciprocal of cosine is called secant of an angle. And then in short, we just call it as secant of x, secant of x. Sometimes some textbooks, I believe they use as this is called secant of x. And then we have to know that secant of x is always the reciprocal of cosine, always. So whatever the cosine value is, you can just flip it over and you will find the secant value. But if you want to find the secant value directly by using a ratio, it's hypotenuse over adjacent. But we use the fact of secant is reciprocal of cosine more than using this ratio. And finally, reciprocal of sine is called cosecant of x, cosecant of x. And then if you want to find the cosecant of x using your triangle, it will be always hypotenuse over opposite side. Again, we use the cosecant being 1 over sine x, this fact more than this ratio. Knowing these 6 functions are very important. One other thing I want to teach you is we have this main angles, and you need to memorize the sine, cosine, tangent value for some trig main angles. These angles are 0, 30 degree, 45 degrees, 60 degrees, 90 degrees. These are like our main base angles. Everybody is going to kind of depend on them, okay? And then we're going to learn how to convert a degree to a radian. So all of these angles, we can represent them as a degree or we can represent them as a radian. So when I say 90 degree, 90 degree is the exact same thing as pi over 2. The difference is when I say 90 degrees, the unit here I'm using is a degree. But when I say pi over 2, I am using a radian measure. Pi over 2 is a radian measure. So every time we see the pi in trig class, we have to know that this is equal to a 180 degrees. So pi is in radian measure, but then when I use the 180 degrees, this is in degree measure, okay? Also, if you use the actual value of pi, which is about 3.14, I know it's not exact to 3.14, it's there's more numbers following the 4 and this is still a radian measure for angles, okay? So knowing the degree and radian conversion is a fundamental fact for this class. You have to know how to convert. So if somebody asks me convert 45 degrees to radian, I'm going to say, okay, I just need to multiply 45 by pi over 180. Why am I multiplying for pi over 180? Because pi is 180 degrees, and then pi over 180 is, we're basically multiplying this just by 1. So then you get 45 pi over 180, but you can't leave your answer like this. You have to simplify your fraction. 45 goes into 184 times. So 45 degrees is the exact same thing as pi over 4. So when somebody says 45 degrees, they're talking about pi over 4. If they're using pi over 4, they're talking about 45 degrees. You have to know that when they say pi over 4, they're using the radian as a unit for the angle. If they are using 45 degrees, they're using degrees for the angle. Okay, that's what is important. If we go back here, if you can memorize the trig values for these 5 angles, you can kind of derive everybody else from these. So here's what we're going to do. We will place these angles on a chart from smallest to greatest. 0 degree, 30 degrees, 45 degrees, 60 degrees, 90 degrees. That's where we're going to stop. And then the first line will be the sine of these angles. And then the second line will be the cosine. I'm going to actually need 6. And then 3, 4, 5, 6. I think I should have, that's not a good picture than this, but it's okay. Tangents, all tangents. It doesn't matter the order as long as you know which one is the reciprocal of the other one. So I am going to write the cosecant first, because cosecant is just reciprocal of sine. And then here, I'm just going to write the secant. Since I didn't use the angle for any of them, I'm just going to get rid of this x2 so they can all have the same format. Okay. Now the rest is very important. Let's use here. Okay, so we have to know the sine, cosine, tangent values for these critical angles. So first thing is, I want to find their sine value. All I'm going to do is place 0, 1, 2, 3, 4 in order. And then I'm not done with them yet. Then I'm going to take the square root of all these numbers. And then I'm going to divide them by 2. That's the process to generate the sine values for these angles. That's it. Okay. Now, the rest of them is just simplification. Once I simplify these numbers, I will have the sine of 0. I will have the sine of 30 degrees. I will have the sine of 45. I will have the sine of 60. And I will have the sine of 90. I want to show you the process one more time. So if we do undo, let's do the undo quickly instead of erasing our chart. So I will be calculating the sine values for these 5 angles. So first step will be 0, 1, 2, 3, 4. And then we're going to take the square root of all these numbers. And then we're going to divide them by 2. Okay. Then you can simplify them any order you like. So square root of 0 is 0. When you divide it by 2, 0 divided by 2 is still a 0. So this means sine of 0 will be a 0. Sine of 0 is a 0. Next, square root of 1 is 1. When you divide it by 2, you will get 1 over 2. So that means sine of 30 is basically just 1 over 2. There is nothing to simplify here because you cannot simplify square root of 2 over 2. So sine of 45 is square root of 2 over 2. Same thing here. There's nothing to simplify here. Sine 60 is square root of 3 over 2. So that stays as your sine value for 60 degrees. We have to simplify this. Square root of 4 is a 2. And now you need to also divide it by a 2. So 2 divided by 2 is 1. So therefore, sine of 90 degrees will be just a 1. That's how you do this. Sine of 90 is 1. Now, because cosine is reciprocal of sine, to generate the cosine values of these 5 angles, I am just going to write these 5 values in reverse order. So if sine of 90 is 1, cosine of 0 will be 1. So basically, to generate the next line, we're just going to write these numbers in reverse order. So 1 comes here, square root of 3 over 2 goes here, root 2 over 2 is in the middle, so it stays in the middle. 1/2 goes as a fourth number, and 0 goes as the last number because it was the first number on the first line. So if you interpret what these numbers represent, cosine of 0 is 1, cosine of 30 is root 3 over 2, cosine of 45 is root 2 over 2, cosine of 60 is 1/2, and cosine 90 is 0. Now, because tangent is, I think I should just open some room here to explain more stuff on the same line. And then on the next line, because tangent of any angle is always sine value over cosine value. So this is called quotient identity. And then you're gonna have to know these names for the future chapters. And then tangent of any angle is always its sine value divided by cosine value. So once you have the sine value and cosine value for any angle, it's very easy to find their tangent value because all you have to do is divide their sine value by their cosine value. So for example, for 0 degree, its sine of 0 is 0 because we just calculated on the first line, and cosine of 0 is 1. And if somebody asks me what is the tangent value for 0, I just have to know that tangent 0 is always equal to sine 0 over cosine 0. And sine 0 is 0, cosine 0 is 1. And if you divide 0 by 1, you simply get a 0. So we're going to just divide 1/2 by root 3 over 2 to find the tangent of 30. So let's do that here. For 30 degrees, I should do this. I'm just going to make sure that I didn't scan anything from the chart. And it does scan a little bit, so I'm going to scan it similar. Okay. And then we can just use a simple eraser here to erase this extra line. So I want to calculate the tangent of 30. So to calculate tangent of 30, we need to divide sine of 30 degree by the cosine of 30 degree. So sine 30 is 1/2. And then cosine 30 is root 3 over 2. So basically, I just need to divide these two fractions. And if I remember my basic math rules, to divide two fractions, copy the first one, and then multiply it by the reciprocal of the other one. So this one cancels this one. and then you get 1 over root 3. So you are very welcome to write 1 over root 3 here as a tangent value. But if you remember, math people, they don't like to leave a radical in the denominator. Therefore, they like to rationalize the denominator by multiplying the top and bottom by the same number. So 1 times root 3 is root 3, and then root 3 times root 3 is just a 3. So instead of calling tangent 30 as 1 over root 3, they basically use as root 3 over 3, but they represent the same number. So tangent 45 is kind of very easy. It has the same sine value and same cosine value. So when you divide the same number by the same number, you just get 1. Next, for 60 degrees, we are going to divide we're gonna just, for 60 degree, for tangent of 60, I need to divide sine value by the cosine value. So I need to divide root 3 over 2 by 1/2. Again, copy the first one, multiply it by the reciprocal of the other one. So these two will cancel out. And then tangent of 60 is just equal to a root 3 over 1, which is just root 3. If you like, you can write it as a root 3 over 1. So when we need to get the reciprocal of this number, you will get it easier. Now, this is a tricky one. For tangent 90, I need to divide its sine value by its cosine value. But when you divide 1 by 0, any number divided by 0 is undefined. Therefore, tangent 90 is undefined because in order to produce tangent 90, you need to divide 1 by 0. Any number divided by 0 is always undefined. Now, our work is very easy for cotangent because remember, cotangent is reciprocal of tangent. So all these things are generated. We're just going to write them in reverse order. So undefined will come here. And then root 3 over 1, which is just root 3, will come here. 1 is in the middle. It'll stay in the middle. Root 3 over 3 will come here. And 0 goes last. So tangent of 0 is 0. But cotangent of 90 is 0. So if two angles are complementary angles, if their sum is 90, tangent of the first angle will be the cotangent of the other angle. Now, because cosecant is reciprocal of sine, all I have to do is on this line, I need to calculate the 1 over these values. So I'm just going to get the reciprocal of 0. When you say 0, you actually have 0 over 1. When you get its reciprocal, it will become 1 over 0, which becomes undefined here. Reciprocal of 1 over 2 is just 2 over 1, which is just 2. Reciprocal of root 2 over 2 is 2 over root 2. And then if you simplify 2 over root 2, you just get root 2 because this is root 2 times root 2, and then root 2's will cancel out. Reciprocal of this will be 2 over root 3, and then you can rationalize it by multiplying the top and bottom by root 3, so you get 2 root 3 over 3. And reciprocal of this one is 1 over 1, which is still a 1. Again, secant is reciprocal of cosecant, so you don't have to do this work again. Just write all these numbers in reverse order. So 1 comes first, 2 root 3 over 3 goes next. Root 2 is in the middle, stays in the middle. 2 will become the fourth ratio, and fifth will become the undefined. So that's how we can generate the trig values for these 5 key angles. Besides these 5 key angles, using these, now what we can do is we can use something called reference angles. Very important in this 13-16 class, reference angles. So when you have a 60 degree, if the angle is already in quadrant, so let's do this. We're just going to write angle and reference angle. So I'm going to create 2 charts. So I will have angle, and I will have a column for its reference angle. And then to calculate the reference angle, we just have to pay attention where the original angle is located. Is it in first quadrant or second quadrant or third quadrant or fourth quadrant? So I'm going to use my 60 degree. 60 degree, if we again show this is our x-axis, this is our y-axis. In 13-16 class, we don't call them x and y anymore. So this will be the cosine axis, and then this will be the sine axis. So we just have to know that y is the sine, and then x will be the cosine. So for 60 degrees, this is always where we start when we are drawing the angles, and then this is our 90 degree, right? So this is the 90 degree, this is our 180 degree, this is the 270 degree, and this is always our 0, which is the same thing as 360 degrees. For 60 degrees, we start from here. We don't go all the way to 90, we just stop somewhere here. This is where I place my 60-degree angle. If the angle is already in the first quadrant, its reference angle is itself. So no work is needed if the angle is already in the first quadrant. If you have an angle like 120, and now if I draw 120 here, so let's see if I can actually erase my 60. So 120 is going to start from the same location, but then when I draw the line here, that's just a 90 degrees, so I need to go further, 30 more. So this is my 30 more, and then this is my 90. Now I have a total of 120. So 120, angle 120 starts from here, and then this is the terminal side. So this is my 120-degree angle here. Its reference angle will be 180 minus 120, which will be equal to 60 degrees. So even though angle is 120, we're going to use the values for 60 degrees. So when somebody asks me what is sine of 120, I'm just going to think, okay, what's the reference angle for this 60 degree? So one sine of 120 will be the exact same thing as sine of 60. And then I'm going to go to the chart we created together on the very first page, sine of 60. And then 60 was the fourth angle, I believe. This is sine 60, and its sine value is root 3 over 2. So I know that sine of 60 is root 3 over 2. Therefore, sine of 120 will be also equal to root 3 over 2. So if we just find the reference angle for each angle, and then they're going to all refer to one of these acute angles, either 30 degrees, 60 degrees, 45 degrees, and then we can calculate their trig values easily. The one other thing is we just have to pay attention to the sign for the trig values. So that's how we calculate the reference angle if the angle is in the second quadrant. We always have to do 180 minus the given angle, and then we calculate the reference angle. Now, next thing I want to show you is 240 degrees. Again, if I need to draw where 240 starts and where does it end on this line, I'm going to make this y-axis again. Even 240 has to start on the same start line, and then I need to keep going until I find the angle 240. If I go this much, that's just a 90. If I just finish the other quarter, that's total of 180. So I need to go further. I just need to go 60 more and then end up here. So this whole thing now, 180 plus 60 here, 180 plus 60 is a 240 degrees. That's how I can show the 240 degrees. And I need to find the reference angle for 240. The way we do this is 240 minus 180, which will be at 60 degrees. Even 240 is going to have the exact same fractions as 60 degree when it comes to sine, cosine, tangent, cotangent, secant, and cosecant. The difference will be just a sign. When I say just a sign, okay, we'll explain this in the next slide. And then one last thing is, what about 300 degrees? If we use the same approach for 300, we'll start here. And then if you go these 3 full quarters, that's 270. And then you just have to go 30 more. And then this is going to end. So this whole thing now will represent the 300 degrees. And how am I going to find what it is using as a reference angle? We will do 360 minus 300. And then we're going to find 60 degree as the reference angle again for 300. So I want to just do one more example so you can understand it. So let's use 45 degrees. 45. So I'm going to do the angle, reference angle. And then we're going to find the reference angles for 45, 135, 225, and then 350. Okay, so I'm going to think about 45. 45 is in quadrant 1. In quadrant 1, the reference angle is the same thing as the angle. So its reference angle is the same. For 135, anything more than 90 is in quadrant 2, because quadrant 1 is from 0 to 90. Anything after 90 to 180, those angles, they end in quadrant 2. So to find the reference angle for 135, I need to do 180 minus 135, which would give me a 45 degrees again. 225. So this is my 180. 180 starts here, and then 270 is here. Anything between 180 and 270, those angles, their terminal side is in quadrant 3. So this is a quadrant 3 angle. To find its reference angle, we always do 225 minus 180, and then that will be a 45 degrees again. For 315, 315 is a quadrant 4 angle. And to find its reference angle, the rule is always we need to do 360 minus 315. Even that will give me a 45 degrees. Okay. And then one other thing we have to talk about is we said in trig class, this axis, x-axis, we just call it as the cosine axis. And now we just call this as our sine axis. If you remember our regular rectangular coordinate system, x values are here positive, but on the left side, it is negative. Sine values are on the above the x-axis, they are positive numbers, but below the x-axis, they are negative numbers, right? So when it becomes cosine and sine, whoever the angle who lives in quadrant 1, their cosine value is positive, and their sine value is also positive. So the first one is always cosine, and then the other one is always sine, cosine and sine. So if you have any angle whose terminal side is in quadrant 1, don't forget their cosine value is positive, their sine value is positive. So you can think about the signs for other trig values using these two main things. For quadrant 2, now we have these negative cosine values. If you have any angle whose terminal side is in quadrant 2, that means their cosine value will be always a negative number, and their sine value will be always a positive number. So this will be the case if you have any angle who ends in quadrant 2. This is our quadrant 3. Quadrant 3, cosine is negative and sine is negative. So don't forget the first one, always the sign for cosine. The next one is sine for sine. So third quadrant, both cosine is negative and sine is negative. And then the last one here is the cosine values are positive, but the sine values are negative. So if any angle ends at quadrant 4, their cosine value is positive, but their sine value is negative. Now, this is how I was teaching to my students. If you don't remember the signs for these quadrants, you can use this, add sugar to coffee, which means if you know the signs for sine, cosine, and tangent. So this video actually compares the signs for sine, cosine, and tangent. So this is our add, which means all of them are positive here. If sine is positive, cosine is positive, then tangent is sine over cosine, even tangent is positive. Cotangent is reciprocal of tangent, so even cotangent is positive. So basically, quadrant 1, everybody is positive, so all. Sugar in quadrant 2, sugar represents the sine. Only sine positive in quadrant 2, cosine is negative. Because tangent is positive over negative, tangent will be negative. So only sine will be negative. Sorry, sine will be positive. So this is actually telling you which one will be positive. And quadrant 3, both sine is negative, cosine is negative, but because tangent of any angle is always sine over cosine, since the sine is a negative number, cosine is negative number, and when you divide negative by negative, it's a positive number. So in quadrant 3, sine is negative, cosine is negative. but only tangent will be a positive value. In quadrant 4, coffee represents the cosine, so only cosine will be positive and tangent and sine, they will be both negative numbers. So after we learn this much information, how are we going to use all these facts? And then what do we do? For example, somebody asks me to calculate the 6 trig values for 210 degrees. So I need to find the sine of 210 for them. I need to find cosine of 210 for them. I need to find tangent of 210 for them. And I need to find reciprocal of sine as cosecant. So I'm going to write cosecant of 210 first. And then I'm going to write the reciprocal of cosine as secant of 210. And then reciprocal of tangent is cotangent of 210. So basically, if I just calculate the 3 of these, I will just get the reciprocal and find the other 3 as well. So first thing I'm going to do is I'm going to find the reference angle for 210 because 210 is not something I memorized. So 210 lives in quadrant 3. How do I know? From 0 to 90, all angles are in quadrant 1. This is my 90 degree, and then this is my 0 degree. So this is not a quadrant 1 because it's more than 90. Quadrant 2 angles, they are more than 90, but they go all the way to 180 degrees, so they are called quadrant 2 angles. So this is not in quadrant 2. So this is a quadrant 3 angle because quadrant 3 starts from 180, but it ends in at 270. Because 210 is between these two numbers, I know that this is in quadrant 3. And the rule to find the reference angle in quadrant 3 is the given angle minus 180, as I showed you on the other first 2 examples. So the reference angle is 30 degrees. Basically, if I calculate sine of 30, cosine of 30, and then tangent of 30, and cosecant of 30, a secant of 30, and cotangent of 30, it will be very easy for me to find what they really want from me. To find these values, we already created a chart. It's like 0, 30, 45, 60, 90 thing that I showed you how we, and then the first one is always the sine values. I showed you how we place the 0, 1, 2, 3, 4, and then we take the square root of these numbers, and then we just divide them by 2, and then we can simplify these fractions. But because we're going to use these values so much, we're going to actually memorize. So sine of 30 is 1 over 2, and everybody takes math 13, 16, 4, really knows this. Cosine of 30 is root 3 over 2. Okay, it comes from this chart, basically, but everybody memorizes by the time that cosine of 30 is root 3 over 2. Tangent of 30 is if we just divide these two fractions, 1/2 divided by root 3 over 2. Basically, I'm just going to multiply it by its reciprocal. I get 1 over root 3. And then we just multiply top and bottom by this root 3. And then we end up getting root 3 over 3. Now, these 3 are very easy. We're just going to get the reciprocal of this. Reciprocal of 1 over 2 is just 2 over 1, which is basically 2. Reciprocal of root 3 over 2 is 2 over root 3. Basically the same thing as 2 root 3 over 3. Reciprocal of root 3 over 3 is 3 over root 3, which is basically just a root 3. Now, all of these ratios will be copied to 210 with a difference that I have to pay attention to the sign. So remember what we said, 210 is in a third quadrant angle. So in third quadrant, I have to decide which one is a positive trig function, which one is a negative function. So in quadrant 3, because 210 is quadrant 3, we know that cosine, because the first one always represents the cosine. Cosine is these x values, they're negative. Sine is y values, they're negative. So we know that for 210, we will have a negative value. Cosine will be a negative value, but tangent is positive because negative divided by negative is positive. Cosecant always uses the same sign of sine. secant always uses the same sign of cosine, and cotangent always uses the same sign of tangent. Once we decide the signs, rest of it is very easy. We're just going to copy these. Sine of 30 is 1/2, so sine of 210 is negative 1/2. Cosine of 30 is √3/2, so cosine of 210 is negative √3/2. Tangent of 30 is √3/3, so tangent 210 is positive √3/3. And then cosine of 30 is 2, so this will be a negative 2. Secant of 30 is 2 √3/3, so secant of 210 will be negative √3/3. Cotangent of 210, it's a positive number, and it will copy the number from the 30 degree, so it will be the √3. That's how we're going to do these questions on this homework. So this is a very important homework, so please make sure that you understand these fundamental knowledge before you start your homework. So for homework 1.3, the first question is, they gave us the angle. They didn't mention what angle it is, but they did such a good job that the angle starts from our regular start line and it terminates here. And then it's kind of showing me the reference angle. Remember, because this angle is in third quadrant, its reference angle is given angle minus 180. So from this given angle, if I subtract the 180 portion, I'm just going to end up with this acute angle here. So for this question, even though there's a lot going on in the picture, I know that what is important for me is this is my reference angle here. So I'm going to calculate everything according to this reference angle. But I have to make sure that because it's in third quadrant, quadrant 3 angle, I know that its sine value will be negative, cosine value will be negative, but its tangent value will be positive because negative over negative. And then the question says that it ends at -5, -5. Why is this coordinate important? Because I know that its opposite side is 5 units and its adjacent side is 5 units. So sine and cosine needs the hypotenuse value, but for this question, they are just asking for the tangent value. So tangent value of this angle, so I'm just going to call it x. Tangent x is, tangent is opposite over adjacent, so I need 5/5, which is just a 1, right? But, and it will be a positive value because in quadrant 3, tangent is a positive number. So this is what they want here on the question 1 for this question. For question 2, sketch an angle theta in standard position such that theta has the least possible positive measure and the point -5, 12 is on the terminal side of theta. So what this question says that if I just sketch the graph here, and then let's just show the point first, -5, 12, 1, 2, 3, 4, 5. This must be the -5, and I need +12, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm just going to actually pretend like this is a 12. So the terminal side will end up at this point. So this will be the terminal side. And all these angles, this is their start point. So this is what we have here as an angle. So we're going to see among these answer choices, this is quadrant 2. So the terminal side is going to be in quadrant 2. Look, answer 1, it's a quadrant 1 angle. If you look at B, B's terminal side is in quadrant 4. If you look at C, C is what I'm looking for. It starts at 0, and its terminal side is in quadrant 2. So I don't know if I can make this bigger here. So I'm going to choose C, and then this is how I am going to handle this part of the question. Now, this question is asking me if I can find the sine of theta next. So because I need the sine of theta next, so this is what it looked like. The angle started here, angle ended up here, and then this is the right triangle we had here. And then this length is 12 units, and then this length is 5 units. So this is the whole angle, but remember its reference angle is this one, because any angle using the second quadrant to find the reference angle, we do 180 minus given angle. And when I do 180 minus given angle, this will be the reference angle. So if this will be the triangle that I need to focus, its opposite side is 12, its adjacent side is 5, because it is asking for the sine of this angle, let me call this alpha. So I need opposite over hypotenuse. So opposite side is 12, adjacent side is 5, but hypotenuse is missing. So I need to do the Pythagorean theorem. So I need to do 5 squared plus 12 squared is equal to c squared. That's 25 plus 144 is c squared, and 169 is c squared. So c will be square root of 169, which will be 13. So for these given conditions, hypotenuse must be 13. So for this, finally, I'm ready to work on the problem that they asked. For the sine of alpha, so let's just find the reference angle sine value. It's opposite over hypotenuse. So it's 12 over 13. But for the question, for this bigger angle, when I'm thinking about the sine value, its sine value will be the same numerical fraction as this green angle. It will be still 12 over 13, but I just have to think about the sine. All reference angles, they use these positive values because they are acute angles, but this is a quadrant 2 angle. In quadrant 2, sine is positive, but cosine is negative. Since this is asking for the sine, it will be still a positive number. But if it was asking the cosine value, I would make it a negative number. So on this question on the homework, so let me just show you the screen. For this question, we're going to say that sine value will be equal to, we got 12 over 13, I believe. It's a positive ratio. That's how we're going to do questions. Oh, now it's asking for the cosine. So again, cosine value will be 5 over 13, the reference angle's cosine value, but it will be negative. Then it's going to ask me the tangent value. To find the tangent, this fraction must be divided by this fraction, and then write the first fraction, multiply it by the reciprocal of the second fraction, and you will get negative 12 over 5. Cosecant is always reciprocal of secant, so secant is reciprocal of sines. Sine is 12 over 13, so I will need here 13 over 12. And secant is reciprocal of cosine. Since cosine is negative 5 over 13, its reciprocal is negative 13 over 5. This is how we're going to do question 2. It asks also for cotangent of theta, so I need reciprocal of tangent, so that will be negative 5 over 12. Finally, this answer concludes question 2. So question 3 is a very similar example to question 3. It's going to first ask us to locate the angle, and then we're going to calculate the check values for this angle. Let's see. So terminal side is 6, negative 8. X value is positive 6, Y value is negative 8. So 6 and negative 8. So if you think about, and I want to make this bigger for you, this point here is positive 6 and negative 8. So this is our start line, and this is our end line. So the angle starts from our start line and goes all the way to our end line. This is the angle we're going to study. And if you look at this main angle ends in quadrant 4. So I know that in quadrant 4, cosine is positive, sine is negative. So I have to remember this. Cosine value will be a positive value, sine value will be a negative value. So the first thing is, this will be the answer for part A. Now, in order to find the sine, cosine, and tangent value for this angle, I need to find its reference angle. Remember, if an angle ends in quadrant 4, its reference angle is 360, which is the whole circle, minus the given angle. So the reference angle is just this one here. So I'm going to calculate everything for this acute angle. So for this acute angle, the opposite side is 8 units, but then the adjacent side will be 6 units. So whatever those fractions for this small angle, it will be the same fractions for this main question, but I have to be careful with the signs. So let's do this now. We're going to go to the, I think it will be smart to just capture the picture here for our graph, and then when we share our code, okay. So again, the reference angle, so we're going to draw the triangle for the reference angle. This is the reference angle we need. So I don't need this whole thing, but I do need to copy the triangle here. And then I'm going to call the reference angle as X and the questions angle, so original angle, we're going to call it as Y. And then, so because this triangle here, we have the knowledge of the reference angle. This is my reference angle X. For the reference angle X, I know that opposite side is 8 units. And then the adjacent side is 6 units. And then because this is a 90-degree triangle, right triangle, 6, 8, if you do the Pythagorean theorem, you're going to find that the missing side hypotenuse must be 10. So look, now, sine of the reference angle, so sine of X. Sine is opposite over hypotenuse, so I need 8 over 10, which is 4 over 5. So for using this, I should be able to find the sine of the question that I asked me. So the y, when I say y, I'm talking about this whole angle which was in the problem. The angle started from this line, and its terminal side is here. This kind of brown color is my main angle in the question. But then here, X is my reference angle. So this is my X reference angle, but I'm trying to calculate everything for Y. So if sine of X is 4 over 5, but our main angle Y ends it in quadrant 4, in quadrant 4, cosine is positive, but the sine value will be negative. So sine value will be the same thing, but it will be negative. So negative 4 over 5. So let's calculate the cosine of the reference angle. So this is my reference angle triangle. Cosine is adjacent over hypotenuse. So adjacent side is 6, hypotenuse is 10. So the ratio I'm looking for is 3 over 5. But when I think about then the cosine value of this bigger angle, which is what the question is asking me, cosine is still positive in the fourth quadrant, and it will be still at positive 3 over 5. Tangent of the reference angle, tangent is opposite over adjacent, so I need 8 over 6, which will be simplified to 4 over 3. So tangent of this big angle will be the same fraction, but I just have to think about the sign. In quadrant 4, sine is negative, cosine is positive, so tangent will be negative. Whenever the sine and cosine, they have opposite signs, tangent must be a negative value. And then they're going to ask me 3 other trig functions here, okay, which is kind of easy. Let's just change colors so we will understand that reciprocal of sine is cosecant of x. It's just the reciprocal of this, which is 5 over 4. So I don't even have to calculate these small ones anymore because the question will ask me to enter these values in the green box because question is concerned about y, not my reference angle. So reciprocal of sine is cosecant of y, which is just negative 5 over 4. Reciprocal of cosine is secant of y. The reciprocal of 3 over 5 is just 5 over 3. And then reciprocal of tangent is cotangent of y. So reciprocal of this fraction will be negative 3 over 4. So in the next question, this question 3 on the homework, you will enter these numbers for the homework. Okay, so I have these questions a lot of times for you to practice. So if you need help again with the next question, which is the same style, listen to the video again, and then you can also help me solve this with an example, or you can click on get more help to see if anything is useful. But if you can see, I just put different numbers, different terminal sides. So this time x value is negative, y value is positive. So this is gonna be in quadrant 2. So it will start always the same line, but -5 and +12 is this point that they showed me. For example, this question, this will be the angle representation. And then you're gonna find its reference angle, calculate the values for reference angle. Using the reference angle, you will calculate the values for the bigger picture, for the bigger angle. So I have a lot of these examples. And then finally, I have these simpler questions and shorter questions that we're going to actually calculate these numerical problems. So let's do this. And then I will go back here, open some room. Okay. When I need to evaluate 5 tangent of 0 minus 5 cosecant of 90. If you haven't memorized these values yet, you are very welcome to create the chart. As I showed you before, you need 0, 30, 45, 60, 90. And then don't forget the first one always generates the sign values. Then for cosine, you will just write the numbers in reverse order, right? And then the tangent will be this over this. You can always create, and then to create it, if you remember, you're gonna put 0, 1, 2, 3, 4. Take their square roots and then divide them by 2. So when you simplify these, your assigned values will be waiting for you. If you haven't memorized them, create this chart on a piece of paper, keep it handy while you're doing any homework until you memorize it. All right, 5 times tangent of 0. So I can either just manually think sine 0, this is my 0, for 0 degree. Cosine is the first number, sine is the next number. Cosine value is 1, sine value is 0. So tangent means sine over cosine. So 0 divided by 1 is just a 0. So I need 5 times 0 here, minus 5 times cosecant of 90. Cosecant of 90 is the reciprocal of sine 90. So this is where my 90 degree is. And of the 90 degree, it's located at 0, 1. So its cosine value is 0, but its sine value is 1. So cosecant of 90 will be just 1 because sine 90 is 1. So I need to do 5 times 0 minus 5 times 1, which is a 0, and this is a 5. And 0 minus 5 will be just a -5 to this question. So it's very important that you memorize these famous angles, and then you can evaluate these questions. So next is 6 times cosine of 270 minus 7 times cosecant of 270. Now, remember 270 is not one of those angles that I memorized, but I can find its reference angle. But actually 270 is a quadrantal angle. What quadrantal angle means is 0 degree is a quadrantal angle. And on the unit circle, if you look at the coordinates, the first coordinate here is 1, 0. The coordinate here is x value is 0, y value is 1. Coordinate here is x is -1, y is 0. Here, x is 0, y is -1. This is the location for 0 degree. This is the location for 90 degree. This is the location for 180 degree. This is the location for 270 degree, which is what we had in the problem. And don't forget, the first number represents the cosine value. Second number represents the sine value. So 6 times cosine of 270. Cosine of 270 is 0 minus 7 times cosecant of 270. Cosecant is reciprocal of sine. So sine of 270 is -1. So I will need here 6 times 0 minus 7 times 1 over -1. 1 over -1 is still -1. And when you multiply -7 by -1, that makes a +7. And those two make a 0. And then the final answer will be here just a 7. Next question will be a very similar one, but they're changing the problem. Maybe they're even keeping it longer. So just pay attention to the orders of operations when you're doing this. 5 times cosine of 270 plus 7 times cosecant of 270 plus 7 times secant of 180 degrees squared. This is what we need. Okay, so again, as we talked about this is our 270. This is the location for 270 because this is 0, this is 90, this is 180, this is our 270. Its coordinate is x value is 0, y value is -1. X means the cosine value, y means the sine value, right? So if we start plugging the numbers 5 times, cosine of 270 is 0, plus 7 times, this is the reciprocal of sine, its sine value is -1, so its reciprocal is still -1, and plus 7 times secant of 180, secant of 180 is reciprocal of cosine of 180. This is where the location for 180 is. 180, its x value is -1, y value is 0. So its cosine value is -1. When I need to calculate its reciprocal, it's still -1. So secant of 180 is -1, and they want me to square this number because secant of 180 is being squared. 5 times 0 is 0. When I multiply these two numbers, that give me a -7. Remember the PEMDAS, you have to do the exponent first, which is 1, then multiply by the number 7. And when we add these three numbers, the result will be just a 0 for this question. The last question on this homework will be what we have done so far. I need cosine of 0 squared minus sine of 90 squared. Again, cosine of 0 is 1, so we need to square this. Sine of 90 is 1, and then we need to square this. 1 squared is 1, 1 squared is 1, so the answer will be just equal to 0. And this is how we're going to do the 1.3. It's a very important homework. Please make sure that you understand all these questions by understanding. And then 10 is very similar to what we have done. And then this one is just a very similar, but it's third power and eighth power. And then before we start doing this question, I want to also talk about this. Cosine is an even function. I don't know if you remember this from college algebra, but what it means is cosine of a negative angle is always equal to the cosine of the positive version. So when you are using cosine, having a negative sign in front of the angle, remember negative represents a direction. So negative doesn't mean any change, they will still give you the same answer. But sine is an odd function, so that means that cosine, a sine of -30 will be the same fraction, but it will be the negative sine of 30. So that's odd function, that's cosine is an even function. So when you have a negative angle with cosine, you just ignore the negative because it's going to still return you the same answer. But when you have a negative angle with a sine function, make sure that you treat it as negative of sine of that angle. And then you can answer that question 11 accordingly. And then for question 12, again, sine is an odd function. So let's just do the 12 before we finish this video. Look, when I see this question number 12, it's asking me sine of -270, but when I calculate the sine of -270, they want me to square this number, plus, then they want me to get cosine of -90, and then square its value, and they want us to add them up. This is the question. So what I'm saying is, sine of -270 is the same thing as negative of sine of 270. And then once I get this ratio, I'm going to square it. Cosine of -90 is the exact same thing as cosine of 90, so I can just ignore the negative and I can treat this as the same thing as cosine of 90. But once I get its value, I'm going to square it, then I will add these two things. Sine of 270, remember 270 is this quadrantal angle, lives right here. its cosine value is 0, but its sine value is -1 because the first one is always a cosine, and then the second one is always sine value. So its sine value is -1. So I need negative of -1, and then we're going to square it. 90 is right here. For cosine 90, its cosine value is 0, and then we need to square it. Two negatives here will make it positive. So I have a 1 squared, which is 1, and 0 squared is 0. So that means the sum will be just a 1 here for the last question on homework 1.3. And please do this homework very carefully. If you need to keep generating similar practice questions to understand the concept very well, please feel free to do so.